What's up, everyone? Good morning. Hope everyone's doing well today. Welcome back. I got a new video for us. A very exciting topic. We're going to dive in. We're on a new topic now. We were done with all angles and triangle stuff, and we're moving on. So this is one of my favorite topics of this year. So I hope you guys enjoy it as much as I do, and hopefully you guys can still enjoy it as much as if we were in a regular classroom setting. And I think you guys will, okay? So today we're going to start learning about the Pythagorean Theorem, all right, guys? So that is a theorem you're kind of going to remember for probably the rest of your life. I mean, a lot of my friends still know it when they hear it. So super excited to start showing you guys what this theorem is and how we use it and what it's used for. So let's get started. So the Pythagorean Theorem, it is a theorem made by this man called Pythagoras, who was a mathematician and Greek philosopher in like the 6th century BC, so crazy long ago. And this helped him like build the structures that were made when there was no tools around and no machineries. So this helped him figure out kind of how to fit perfect squares together. So right triangles, right? So you have a perfect square. So that helped him do that. Here's a quote by Pythagoras himself. It's a very interesting quote. I really love this quote. It says, "Reason is immortal, all else is mortal." So I want you guys to kind of think about that. I know you guys have a lot of free time, so read that quote to yourself a couple times and kind of dissect it and see what it means to you. So everyone has Mr. Tone over there. This is a great little quote. You guys can shoot him a remind text and tell him what he thinks about this quote. It's one of my favorite quotes out there. All right. So before we dive into what the Pythagorean Theorem actually is, you guys need to remember how to solve this simple equation. Because when it comes to the Pythagorean Theorem, you're basically going to be solving an equation at one point. So right here, I have a squared with the x term. Now, x isn't by itself, so you have to solve this, right? You have to get x by itself. So somehow I have to get rid of this squared. Now, in order to do that, some of you might know how to do this, some of you might not, but I'm going to tell you right now, it's very simple. To get rid of a squared variable, okay, you need to take the square root of both sides, and that's that symbol in the calculator. Now, you guys have a free calculator that's on my website that you can use, so you can still be able to do this. Basically, what the square root does, guys, is it finds the perfect square in this number. That means that it's multiplying the same number twice to give me that number. So if you guys take the square root of 64, your answer is x equals 8. And how is 8 the answer? Because look, guys, 64 is a perfect square because 8 times 8 is 64. So that's your answer there. All right, so that's how you take the square root. If you want to figure out how I got 8 as the answer, it's basically looking for a perfect square, right? It's looking for a number that can multiply to itself to give you that number, okay? There's a ton of perfect squares. 4, 16, 36 is a perfect square. 64, 25, 100, 144, it goes on and on and on, 121, okay? Because those perfect squares are going to be square root of 4 is 2. See, is 8 a perfect square? No, because there's not two numbers to multiply to give you 8. So that is not a perfect square. So that's a little how you get x by itself here, because you're going to have to do this when we solve for the Pythagorean Theorem. All right. So here's a little show how of what the Pythagorean Theorem is. Now, it deals with triangles. Now, it deals with very specific triangles, right triangles. So the Pythagorean Theorem can be used to find a missing side of a right triangle, or you can use the Pythagorean Theorem to figure out if 3 side lengths will actually make a right triangle. All right, so we're going to be doing both ways, starting very light, very easy, because it's something that I think you guys will enjoy. So we're going to start slow, and we're going to build up to different problems, okay? So this is a great beginner's problem because it shows you exactly what the Pythagorean Theorem is when it comes to squares and stuff, okay? So it says, behold a triangle whose sides have lengths of 3, 4, and 5. So here I have side A, side B, side C. Now side C is something very specific. It's called something very specific in math. Now some of you might be able to see why side C is called something specific and side A and B are just known as the sides here. Is because it's the longest side. So the longest side of a right triangle is known as the hypotenuse. So the hypotenuse is the longest side of a right triangle, or it's opposite the right angle, okay? And we all should know a right angle measures 90 degrees, okay? So it says, let's draw some squares on each side of the triangle. So we know that side A is 3. So I put 3 triangles here. 1, 2, 3. Side B is 4. 1, 2, 3, 4. And side C, also known as the hypotenuse because it's the longest, is 5. So I put 5 squares here. 1, 2, 3, 4, 5. All right. So I got 3. I got 4 triangles and 5 because that's how long it is. It tells me that it's 3 by 4 by 5. Okay. So that's pretty easy. So why do I have other triangles here? So pretend these aren't here right now. There's a specific reason why they're here. Now what I want us to do is then take side 3, 4, and 5 and square it. We should remember from exponents, squaring 3, squaring 4, squaring 5 is going to give us 3 squared. So 3 squared gives us a total of how many? 9. So that's why I had 3, 6, 7, 8, 9 here. Because I took 3 and I squared it, okay? So that looks something like this. 3 squared, right? So we're squaring each side. We are squaring each side of this triangle. Now let's take 4 and square it. If I square 4, 4 squared, 4 times 4 is 16. So then I'm going to have 16 total squares here, okay? And if I do the last thing for side 5, I take 5 squared, which is the hypotenuse side. So if I square 5, I'm going to get 25 individual squares, okay? So since squaring them, it gave me this side 9, this side 16, this side 25. So let's write that down. So side A was, what did we get for side A? Side A, we got 9 total squares. Side B, we got 16 total squares. And side C, I got 25 total squares. Now, since side A is 9, side B is 16, and side C is 25, and I kind of stressed to you guys how important side C is, how side C is known as the hypotenuse. So I'm going to write that here for you guys. So side C, in this case, is the hypotenuse. Because it's the longest side. Okay? So side C is the hypotenuse because it's the longest side. So if I had side C is 25, okay, kind of by itself, guys. Think about it by itself because it's the longest side, it's known as the hypotenuse. Now look at the other two sides, 9 and 16. What do you notice about 9 and 16 there? You guys should come up with this, that if I take 9, if I take the number 9 and add it to 16, so I take the two smaller sides, I add them together, guess what I'm going to get? 25. So indeed, if I had side lengths 3, 4, and 5, those 3 side lengths will form a right triangle because the sum of the squares of the two smaller sides equal the square of the bigger side. Now that may have sounded a little confusing, but I'm going to make it very easy for you guys. The formula for the Pythagorean theorem is, here we go, a squared plus b squared equals c squared. Pythagorean theorem. And what is c squared? The hypotenuse. Hypotenuse, which is the longest side. Bam. And A and B are the two smaller sides, kind of interchangeable there, okay? So A and B are the smaller sides, and C squared is always the hypotenuse, which is the longest side. So you just plug in your numbers here, and if one side equals the next, it is a right triangle. Or if they give you a missing side and they want you to find that side, you plug in what you know, A, B, or C, and then solve for whichever missing letter you might have. So there it is, guys. That's the Pythagorean theorem. A squared plus B squared equals C squared. And what does this theorem do that Pythagoras himself came up with, which is the most famously known theorem, I think one of the famously known theorems out there? It helps us figure out or find the missing side of a right triangle. And there it is. That's the Pythagorean theorem. This is what we're going to kind of work with over the next week or so. So you guys memorize this formula. A and B, I'll write here for you guys. A and B are the two smaller sides. So A and B are the two okay. So A and B are the two smaller sides of the triangle. Now, guys, let me just explain this to you again. The sum of the squares of the two smaller sides will equal the square of the biggest side. Now, think squares here, guys. And I'm going to show you something which I think you guys will really help you understand. So if the two smaller sides, so if I add the two smaller sides together and square them, it should equal the square of the bigger. Okay, it should always be the same for when dealing with a right triangle. Now let's show you this one last thing. You ready? This might help. So watch this video.
And if you'd really like to convince yourself, you could build a turntable with 3 square boxes of equal depth connected to each other around a right triangle. If you fill the largest square with water and spin the turntable, the water from the large square will perfectly fill the 2 smaller ones. The Pythagorean theorem.
So there it is, guys. That is truth. So if you have the squares of the right triangle formed like that, and you put water into the largest square, filled it up to the top, once you rotate it, just like it showed here, it will fill the other 2 smaller squares perfectly up, because it just proves the theorem that the sum of the squares of the 2 smaller sides will always equal the square of the larger side, which is the hypotenuse. Okay? So that was kind of just to show you guys what the Pythagorean theorem is, what we're going to kind of be using it for right triangles, to find the missing side of a right triangle. I can show you really quick what we're going to kind of be doing here. You're going to get a problem that looks like this. That little symbol represents a right angle, which is 90 degrees. So I know this is the right triangle. Since I know it's a right triangle, I can find this missing side. Now, this is an example we did already. So everyone should know that this is the missing side is the hypotenuse, because it's opposite the right angle. So since this is the hypotenuse, this will be C. I know A and B. So if you do the Pythagorean theorem, which is A squared plus B squared equals C squared. So you have A, right? So I have A squared plus B squared equals C squared. Now, if I plug everything, so what's A and B, guys? Well, A and B are 3 and 4 because it's the 2 smaller sides. So now I have 3 squared plus 4 squared equals C squared. Now, what are we solving for? C. Now, 3 squared is 9. 4 squared is 16. equals c squared. 19, 9 plus 26, 9 plus 16 is 25. Now 25 will equal what? C squared. How do you guys get rid of a squared, guys? We did in the beginning today. You take the square root. What's the square root of 25? Well, what number times itself will give me 25, and that is 5. So your answer here is 5. That's how you find the missing side of a right triangle. That's basically it, guys. So really quick intro to Pythagorean Theorem. I'm super excited for us to kind of go down this path now, the Pythagorean Theorem and all about it and what it can do and kind of the converse of it and kind of proving it and showing you guys the inverse of it. And I think you guys will really enjoy it. So hopefully this video was a little informative, guys. I will be posting more stuff shortly so we can talk, so we can be on the same page. But make sure that you kind of watch this video. Make sure you like, subscribe, and please leave a comment if you enjoyed the video. And any questions, you guys know where to reach me. I am Mr. Cornell. We are the Math Fam. And one love. I'll catch you guys later. Peace.